I'm here with Mr. Schoenfeld at Greenfield Elementary School in 5th grade, and he's going to tell you what I'm going to learn today.
All right, well today our concept is exploring one of our physical properties of matter, which is about relative density, whether things sink or float. And the students will use the design process to help guide them through the steps to design a barge that can support at least 30 pennies. So we will kind of model each of those steps. They will plan it out and sketch it out first, and then they will go ahead and design it, test it, and rebuild it or redesign it based on whether it was successful or not. It's called the Build a Barge Challenge. Now I'm going to post a question to start off with. Will the orange sink or float? Think about that. Okay, look at the two types of matter that we have here. What do you notice about them? What makes them similar? What makes them different? Sink or float? How many say sink? Okay, got a couple hands to say sink, but not very many. And we have a lot of people that say float. Hands up if things gonna float. All right, so we're doing the peel, correct? Yes. Okay, most of us think it's going to do what again? Float. We said float, right? What does it do? It sinks. And what do we think this one is going to do?
Float.
I mean, it's going to do the same thing, right? Okay, we'll see. And if you've ever bought for apples, have you ever bought for apples at Halloween time?
Yeah.
Right? They float, don't they? All right, so what we're looking at here is why does that happen? Okay, your challenge today, there we go, is you're going to try to design something that can actually float, okay, without sinking, and support at least 30 pennies.
If we can't make a bowl, we can like make it into like a big rectangle.
Yeah, a rectangle. It's any shape. I said bowl, but it could be a rectangle.
These are bendable.
Yeah.
Yeah.
So right now there's air in the straw.
Yeah.
So, yeah, if they were bent up. How about underneath?
Oh, yeah, underneath. Yeah, that traps the air inside. Put it under, like flat under.
Like that?
Yeah. That's a good idea. Oh gosh. You need a little stick man in it. Oh well. They're too heavy anyway.
5, 6, 7,
80. 81 you want?
82,
83, 84,
Oh my
85.
86,
Starting to sink a little
87,
bit.
88, 89.
I'm gonna tell you 89.
Yeah, it's starting to float. It's starting to sink.
Yeah, it starts to sink a little bit, but
Wait, we were in 89, right?
Yeah.
90,
90,
91,
92, 93, 95,
96, 97, 98, 99.
why don't you stop there and then let's look at put that last 100 on there. That was a very good effort, guys.
Great group. So tell me how y'all figured this out.
Okay, so we first we did teamwork first because we all had a good idea, and then we put it all together to make a good boat, right?
I think the modeling clay kind of helped it out when it would float to keep it sealed so that way like nothing like this would happen, but I don't think we put enough clay so the water got in. But the modeling
I mean,
clay
it still floated after it broke.
I heard somebody in their group say we're not going to win best or prettiest design. I heard somebody mention that. It was funny to hear some. Yeah, but did it work? Now, how many pennies did your group get up to?
103.
Yeah.
Okay, I have no idea if I helped my group or not, but I got the orange question wrong at the beginning. Okay, I've never tried to make a peeled orange float. I knew the regular orange would float, but I didn't know about the others. So after that failure on my part of not knowing that a peeled orange would sink, I was not sure. I was thinking there was trick questions or something, but it all worked out. My group really did a great job and figured it all out. So I was really proud of them.